There are many ways to set up the controls and labels and other elements that make up the user interface of an interactive computer program. For simple applications, often a good place to start is with the manipulate function. Here's a manipulate that gives a program for displaying the distance between 2 points in an image. Manipulate is basically a convenient high-level tool for laying out controls and the display for self-contained applications like this one. The controls in this example are a checkbox for choosing whether or not to apply edge detection to the image, a slider for adjusting contrast, and a pair of locator controls on the image for selecting the endpoints of a line on the image. The display shows the image with the selected points and separately a label and a number giving the distance between those points. Much of the programming in the manipulate input is for labeling and styling and layout. There's a title indicating what the program does. The image and the distance display are arranged as elements in a row. A double-headed arrow is added as a highlight on the image to emphasize the distance that's being measured. The numerical distance and the label are elements in a column. There are style specifications for the fonts and font sizes in the image. Horizontal lines are added using delimiter to provide visual separation between the controls. And the control placement option is included so that the slider and the checkbox are positioned to the left of the display. Without all of that styling, the program might instead look like this, which is probably closer to how a program like this might initially be written. This much shorter program handles basic functionality, including image processing operations and specifications for the two locator controls, the edge detection checkbox, and the slider for adjusting contrast. Styling and labeling and formatting are very important, of course, and can make a program like this much easier to use, and without any labels it could be difficult even to know what this program does, but all of that styling and labeling can be added later. This program could also have been written using separate lower-level functions. Here, for example, is an input that uses individual controls and formatting functions to get much the same result. This program uses dynamic module to localize the variables, panel expressions for arranging the controls and the output, a checkbox control, a manipulator control, which is similar to a slider control, and a locator pane expression for inserting the locator controls. And this program uses dynamic to provide for continuous updating of the display in response to changes in the controls. Manipulate implicitly uses all of these same functions. As already noted, manipulate is essentially a convenient tool for organizing all of these lower-level components. Controls and dynamic expressions are also used implicitly by various other functions, such as view functions like menu view and tab view, and functions like form page that are used for creating a style of user interface called a form. Starting with view functions, this shows menu view returning a program for expanding 1 plus x to the n for various values of n. As with other view functions, the result from menu view consists of a control, in this case a control called a pop-up menu, and a display. The control is used to choose between the various displays or views. A similar result can be obtained using the pop-up menu function and a function called pane selector. So menu view is similar to manipulate in that menu view is also a convenient high-level tool for organizing these lower-level components. View functions are often used in combination with other controls. For example, this input generates a grid of paste buttons for pasting numbers into the selected notebook, and this shows a function called tab view used with that grid and with two similar grids. Across the top of the result is a row of buttons called a setter bar. The buttons in the setter bar can be clicked to select which of the three grids to display. Tab view works much like menu view, except that the control used by tab view is a row of buttons rather than a pop-up menu. Functions for creating forms also use controls. This shows a simple example of the form page function, giving a program where the user interface consists of an input field for entering the name of a chemical and a button. Entering a name and clicking the button causes the name to be interpreted as the name of a chemical. The first argument in form page specifies the control, which here is an input field. The first argument in this example is a rule, where the left side of the rule includes a name that's used for referring to whatever is typed into the input field, and a string that serves as a label on the input field. And the right side of the rule gives the interpreter type that will be used to interpret the input. The interpretation happens when the button is clicked and gives the same result as using interpreter directly with the specified interpreter type. The second argument in form page is a function that's applied to the interpreted input. In this example, that function simply returns that interpreted input. A similar program with an input field and a button that applies an interpreter could also be set up like this using the input field function and a button where the action of the button includes calling that interpreter. An important programming detail when using form page is that the expression that is passed to the function when the button is clicked is an association. To see exactly how that works, here's another form page input that gives a page for adding two numbers. The association that came up internally in that example for passing inputs to the function can be seen by replacing the second argument in form page with the identity function. And now the display shows the association. The names that were used in the first argument of form page to label the inputs become the keys in that association, and the numbers that were typed into the input fields become the values associated with those keys. This association is the argument that is passed to the function, so the function in the second argument of form page should be a function that uses named slots, as in this input, which shows the notation that is used when applying a function to an association. There are lots of other things that can be done within the basic structure of a form. Here, for example, is a form where the controls include radio buttons and a menu and a checkbox. A similar program could also be set up using Manipulate. A difference with Manipulate is that the display from Manipulate is updated continuously whenever a control is changed, while in a form interface like this one, the display is only updated when the button is clicked to submit the current control settings. So far, all of the examples have involved programs where the controls and the results are in the same panel or are otherwise nearby, but there are many situations where it is useful to put controls somewhere else, such as in a palette or in a toolbar or in a dialog box. This grid of buttons, for example, would likely be more useful if the buttons were in a palette, which can be done using Create Palette. The buttons in the notebook can only be used for pasting into the visible part of the notebook that contains the buttons, but the buttons in the palette can be used for pasting anywhere in any selected notebook. Another common location for controls is in a toolbar or in some other fixed location in a window. One such location in Wolfram notebooks is called a docked cell, which can be set up using the docked cells option of the notebook. For example, this input puts one of those grids of buttons in a docked cell for this notebook. A docked cell is a cell that is fixed at the top of the notebook, so it's a cell that functions as a toolbar. The value of the docked cells option is a raw cell expression, which is an expression based on various low-level expressions called boxes that are used for representing cells. There are several ways to get that expression. In this example, the necessary cell expression is constructed using the toBoxes function. Another common place to put controls is in a separate window called a dialog box. For example, this program uses the create dialog function to put up a dialog box while the program is running. The only control in this dialog box is a button labeled OK that can be clicked to close the dialog box. Another function for creating dialog boxes is dialog input. Here's that same program but with create dialog replaced by dialog input. An essential difference between create dialog and dialog input is that the dialog box created by dialog input is a blocking dialog, which means that evaluation is blocked until the dialog box is closed. This program, for example, stops running when the dialog box appears and then continues when the dialog box is closed. Blocking dialogs are typically used when input from the dialog box is needed before a program can continue. For example, a dialog box like this one, created by this dialog input, could be used by an enclosing program to provide a choice about whether to stop or continue running the program. This dialog box returns true if the button labeled stop is clicked and false if the button labeled continue is clicked. The return value from dialog input is specified by the argument in dialog return. As an example of how that dialog box might be used, here's a program that increments a variable and periodically uses dialog input to put up that dialog box. Clicking the continue button causes the program to keep running, and clicking the stop button causes the program to stop and return the value of the counter. There are many details and variants for all of the functions that came up in these examples. Basic background information on controls can be found in the Tech Notes Introduction to Manipulate, Advanced Manipulate functionality, Introduction to Dynamic, Advanced Dynamic Functionality, and in the tech note, Introduction to Control Objects, and by following links to individual functions from the guide page on control objects. For user interfaces more generally, there's this overview page on custom interface construction, which has links to tech notes on controls and views and toolbars and dialog boxes and palettes. And there is also a guide page on custom interface construction, which has links to the documentation for individual functions. For user interfaces based on forms, there is this tech note on advanced web form creation. Most of the functions described in the examples also work on the web, but forms are particularly common in web-based applications.